let's start for a very quick introduction about myself. My name is Alessandro Benedetti. I am from Italy, actually from Tarquinia, a small city, an ancient Etruscan city by the sea in Italy, and I have a master's degree in computer science. I've been working for many years in the Lucene and Solar world. I'm part of the program committee member of ECR, CKR, and the SciES, and I'm a Lucene committer, and recently the chair of the PMC of Apache Solr, and I'm a committer of Apache Solr. Been working with Elasticsearch and OpenSearch quite a while, and in general, I'm passionate about integrating machine learning and artificial intelligence with search. And I also play beach volleyball when I go back to Italy during summer. I live in London, so that's not something that happens during the winter, unfortunately. I direct the company called SEAS. We are headquartered in London, but we are distributed as a company. We are open source enthusiasts. We use open source software, and we contribute back to open source software, mostly Apache Lucene and Solr, but also Elasticsearch, OpenSearch, and more recently Vespa. We are active researchers, so we like to explore the edge of the field, and we contribute it back to the community. So we don't just use open source technology, but we try to give it back through support, blogs, and code contributions and documentation. What trends we are exploring recently, as pretty much everybody, large language models applications to the world of search. Vector-based search, which is going to be something we are going to talk today. Natural language processing in general, for classification, for example, and document enriching. Learning to rank, we've been spending a lot of time on the learning to rank module in Solr. We are still contributing bug fixes and improvement to it, which is the application of machine learning to improve ranking capabilities of search engines. And then also document similarity, so the more like this, to keep it simple. And search call evaluation, we contributed Rated Ranking Evaluator a few years ago, which is a library to evaluate Lucene-based search engines. And we may go back to work a little bit on RRE as well in the near future. We have some ideas. And relevance tuning, which is pretty much a buzzword, right? So it covers everything. So today is going to be end-to-end semantic search. So what's semantic search in this context? Because this term has been quite abused in the last probably, 20, 30 years. So in this talk is going to be semantic search through text vectorization. So you take an input a natural language query, Solr will vectorize it, will do the same at indexing time, so your document will be vectorized as well, and then vector search. So this is the semantic search we're going to talk about today. We're going to start from the use case review. So why do we need this in Apache Solr? What was there? What happened with 9.8 and 9.9? We're going to introduce the large language model module. This is a component that at the moment only involves large language model fine-tune for text vectorization, but in the future can introduce also additional capabilities. Then we're going to start from the indexing time. So how can you use the large language model module to index your document and encode them to vectors directly in Solr? Query time, so what will happen then at query time to interrogate your index and get back documents. So just expressing a natural language query, so you don't need to vectorize it outside Solr. I'm going to wrap up the talk with some future works. So what we want to introduce later in Solr, what's in progress, and what's going to be there soon, and or possibly a little bit later on. So let's start from the use case review. So probably everybody in the room is aware of traditional search problems. The most popular is, and famous actually, is the vocabulary mismatch problem. So this happens when the query terms don't match the terms you have in your documents. So this means that there is like unfortunately, a mismatch between the lexicon used by your users and the lexicon used by your producers of content, your corpus of information. And this can impact your search engine in multiple ways, potentially affecting false positive retrieval. So you may get a query such as like, how many people live in Rome, and get back a document mentioning hundreds of people queuing for live music in Rome. You have a huge intersection between the query terms and the document terms, but the meaning is not there at all. But if you just look at keywords, this seems like a pretty decent match, actually a better match than another document that mentioned Rome's population is 4.3 million, that only have Rome in common with the query. A similar problem can happen with false negatives. So your search engine may not retrieve documents because they don't contain any term in the query. So for a query like, how big is a tiger, a document saying Panthera tigris can reach 390 centimeters nose to tail may not be recovered at all. But it's actually specifying the exact dimension of a tiger, just using a different way of calling the tiger, specifically the scientific name of the tiger. In general, the vocabulary mismatch problem is the fact that human language, many human languages use the same terms for different meanings, and sometimes different terms for the same meaning. So what was in Solr starting from Apache Solr 9.0? So back in the day, the first step was to contribute vector search. So you had to vectorize your documents and your queries outside Solr using a vectorization model, a service, whatever you liked. Encode your documents to vectors, encode your query to vector, and then we see the Solr box in the diagram. So the scope for Solr was just indexing the vectors, so building a data structures to satisfy queries on vectors, and the query implementation, so how to look for k nearest neighbor in terms of nearest vectors to the query vector. This, of course, was interesting. I mean, we've seen many examples of usages of like vector search in Solr. Great, but there's still some potential improvements we can do. And this happened effectively with many things from Solr 9 to Solr 9.7. And these improvements were related, for example, additional filtering capabilities. So supporting lexical filters, pre-filters, so affecting the scope of the vector search, or post-filtering, so processing the results coming from vector search to reduce the result set. Vector similarity function query. So you may want to use the vector distance and the vector similarity as an additional feature in your ranking algorithm. So maybe not the only feature, but one of them. Maybe you have a learning to rank implementation, so you are combining features. You are learning the weight of different features. Vector similarity threshold as a query parser. So potentially you're not interested into a top K retrieval, but in everything that's above a certain threshold. So anything with a score like greater than 0.6, for example, as a score. Or you have high dimensionality. So for a while, Solr only supported up to 1024 elements for vectors. And this has been like extended from Solr 9 to Solr 9.7. Different vector element support, so potentially you don't need 4 bytes per element, so you're happy with smaller elements, cheaper from memory and storage perspective, and hybrid search capabilities. Hybrid search capabilities, there's been some work which is still in progress, to be honest, because there's a lot in Solr by default, so you can combine different queries. I mean, you could do it even before vector search, so you can combine vector search queries, so KNN queries with other queries, like through the Boolean query parser, for example, and playing with the scores, normalizing the scores coming from document. There's no like receiver and rank fusion yet, for example. There is a pull request, has been there for a while, actually, since last year, since last talk, actually, I had in Berlin Buzzword. But what we were missing was this kind of box. So you just push documents to Solr and queries in natural language, and Solr takes care of the vectorization and running behind the scenes vector search. So potentially the user doesn't even need to know that vector search happens behind the scenes. The administrator will configure some vectorization model. Solr will call this model, encode the query or the document fields to vector, and run the KNN search. And why do we need this? Because you may want to prototype a semantic search solution quickly. So you just want to use Solr. Maybe you don't want, you're not building something for production where the vectorization itself needs to be super performant. Maybe you want to just use it directly in Solr. Potentially, you are interested, I mean, your system is not like billions of documents, so the time added by vectorization in Solr is good enough, and you don't need to build anything else. So you just push documents to Solr, queries, and you're good to go. And if you want to do something different, of course, the vector search capabilities are still there. 9.8, the LLM module is introduced. So we are talking about January 2025. So this contribution is quite recent. And this module allows you to configure, first of all, a model and store the configuration of the model. So the configuration for a model is the endpoint for the hosted service that encodes text to vector, an API key, so the license basically to access this service, and potentially other parameters. It uses LangChain4j behind the scenes. So LangChain4j is a Java library. It shares the name with LangChain, but it's not like related to LangChain explicitly. They got inspired by LangChain and implemented the same kind of approach in Java to build an indirection with large language models to do various operations. So for the sake of this talk, we are talking about large language models fine-tuned for sentence similarities that are able to encode text to vector. But LangChain4j supports many other interactions with large language models, also general purpose large language models. So these kind of integrations may come later with additional contributions. So right now, there is support for external text vectorization services only. So let's specify what it means external, right? Here, we are talking about some hosted service, like an HuggingFace, for example, service, Mistral AI, OpenAI, or Cohere. Many more can be implemented, but these are the 4 that are currently available. That takes in input text and returns as output a vector. And they are running somewhere in the cloud and external to Solr, but external also to the local area network, potentially Solr is running. In the future, we plan to extend this support, but this is what's currently supported. So the text encoding happens outside your network, effectively. In terms of components, the LLM module introduces the Solr text to vector model. This is a wrapper for the LangChain4j implementation of embedding models. So there are specific implementations for HuggingFace, Mistral AI, OpenAI, and Cohere. This indirection reads from the configuration and instantiates depending on the configuration in Solr. Then the module introduces the KNN text-to-vector query parser that has the responsibility of encoding the query to vector and run the KNN query. We're going to see how to use these components. Finally, at indexing time, and this is coming with Solr 9.9, which the release is happening as we speak, because we are working towards the first candidate for the release. So it's probably happening within the next month. The text-to-vector update processor has the responsibility of encoding your documents. So you select a field or more than one from your documents and a target vector field, and the content of the input field will be encoded to a vector and stored in Solr. The first step is enabling the module. So you need to enable in your Solr instance the LLM module. It's a standard module, so you can follow the procedures from the Solr documentation. I listed it here, and this can happen through the Solr start script, for example, if you use that, and just specifying the Solr modules and adding the LLM one. You can put it in your Solr XML, potentially, as an XML configuration, or as an environment or system environment variable or system property. You find more information in general about Solr modules in the documentation. It's, as I said, not a special module. The main element in the LLM module are the models. As I said, the model encodes text to vector, but they are not running in process. I stressed this because I want to make sure that you don't think that this happens in Solr using Solr resources. So this has nothing to do with the JVM Solr is running on. And it's represented as a JSON object. So you can define the configuration to access an hosting service for text vectorization through a JSON object that defines, first of all, the class of your model. This is literally the LangChain4j class. And so far, as I mentioned, HuggingFace embedding model is supported, the Mistral AI embedding model, OpenAI, and Cohere. For additional models supported by LangChain4j, you can refer to the LangChain4j documentation, and specifically to a version on LangChain4j that's the same included in Solr. From time to time, I mean, in the following releases, I mean, from 9.9, maybe 10, etc., we may upgrade it from time to time. So take a look to what's in your Solr, and then you can see like what's available in terms of parameters, for example, and even models that can be added and contributed to Solr. The name is the identifier for your model. So this means you can refer to your model at query time or indexing time using this identifier. And then you have an optional list of params that are model-specific. So they can affect, for example, the max retries for a model. They may specify logging capabilities of the model and the API key, and so on and so forth. So how does a model look like in Solr? For HuggingFace, you specify the class HuggingFace embedding model. The name is your identifier, so it doesn't really matter. And then the params. In this case, just the access token, so your license to access the text vectorization, and the model ID, so the model in HuggingFace. So this has nothing to do with your identifier. This identifies the type of model, the type of embedding model you want to use from HuggingFace to encode your text to vector. As I said, different model providers may have different parameters. So in the Mistral AI example, aside from the class, we've seen it already, is the, again, LangChain4j, and then specifically the Mistral AI one. The name, your identifier, the params. In this case, you want to specify the base URL, so potentially where this hosted service is accessible in terms of URL. The API key again, the model name, and then potentially a timeout, logging capabilities. So like if you want the large language model to log, for example, the requests and the responses, and the max retries in case of failure. So this is handled by LangChain4j, and it's logged, of course, also in the Solr logs consequentially. The OpenAI one is pretty much the same of Mistral AI. With Cohere, we may have a slightly different approach because it offers you the capability of deciding if you are encoding your query or your document. So this is an additional parameter. Specifically, is the input type. If you specify search_document, is going to use effectively for that model the variant for documents, so for paragraphs and chunks. And when you specify search_query, it's going to run a slightly different version that's optimized for shorter text and queries. How do you handle like a model after you've defined it in JSON? The first step is uploading the model to Solr. So you have in here a Carl example. Effectively, it just implements like managed resources. So this is pretty similar to many managed resources in Solr for stop words, synonyms, for learning to rank models. It's quite similar. The only difference is that, for example, in comparison to learning to rank models, the model itself the inference time happens in Solr. But the definition and the management of the model in terms of uploading, viewing, modifying it is pretty much the same. So you can view all the models you have uploaded. You can view a specific model, specifying the name, the identifier in your model store, and you can delete a model potentially if you don't need it anymore. So this is pretty standard Solr interaction with managed resources. So how can you use the LLM module at indexing time? Through a component in Solr called update request processor. So the update request processor concept has been in Solr for a while. And these components take in input a document and manipulate the document. So in Solr, a document is a unit of information composed by many fields, and an update request processor takes in input a document and manipulate those fields. Can add fields, can remove fields, can change the content of a field, and processors can be concatenated in chains. So you get a document in input, a document in output, and you can concatenate this with additional processors. Specifically, the update request processor for text vectorization is quite simple. You have an input field, so that's the source of your text. You have an output field. This is a vector field, so where the encoded vector ends up in Solr. And then you have the model, which refers to the same identifier, to the same name you defined and uploaded to the LLM module. So effectively, this gives the update request processor the target for vectorization. So the processor takes a document in input, fetch the content of the input field, call the configurations for the model, get the configuration, access the service, encode the text to vector, and store the vector into the output field. Now, pay attention to the fact that right now this means that your document content is sent to the hosted service. This has like privacy implications and performance implications. So make sure both of them are compatible with your company policies, your use case specifically. And you define a chain, which, as I said, can be composed by many processors. In this case, it's just literally just one text-to-vector update processor and a necessary processor that it's needed by Solr to perform indexing, let's say. So when discussing this pull request, we got an interesting point from Eric, actually, which is in the audience. So what if you want to first index your documents and then add the vectors? So maybe, given the fact that it takes time to vectorize, you want to first index all your documents, get them accessible in your search lexically, so with normal queries, and in the background, add your data structure for vectors. So what's the naive approach for that? You can define two different chains in Solr with different processors. So one chain can be a no vectorization chain. So this chain may just index your documents doing maybe some other manipulation in case they are part of your use case, but no vectorization at all. And then another chain will be exactly the same as the first, plus the vectorization. So you first go through the first chain, so you index all your documents through the first chain, faster, no vectors at all, so no semantic search, but you index everything, so your documents are accessible. And then once that's finished, in the background, you can repeat your indexing, targeting the other chain that will iteratively start adding the vectors. Now, what's the problem with this naive approach? That from the user perspective, vectors will be added, but behind the scenes, Solr will effectively delete document by document and replace the document with the new one, which contains also the vectors. So it's reindexing effectively. What does it mean? You are deleting a lot of documents behind the scenes. Of course, the user doesn't need to know, but in terms of performance, you are deleting a lot of documents. You are affecting, so when you delete the document in Solr and Lucene, it's not eliminated immediately. Actually, this happens when merge happens. So for a while, you will have duplicate documents not accessible in search, but affecting your storage, for example. And the merge factor takes in consideration the size of the segments, so the size of the segments will be bigger, so you may have some problems behind the scenes. So it's a naive approach. Maybe you're prototyping, you don't care, but in case you go with this approach in production, I would be very careful. We can do a little bit better, not massively better, but you can use partial updates. Because with the first example we've seen, with the naive approach, you need to resend your documents entirely. So even from a network perspective, you are pushing again all your documents to Solr. With partial updates, you can update part of your Solr documents. So this means that potentially, again, you define two different chains, one with no vectorization and another one only with the vectorization and the mandatory, of course, processor necessary for Solr to work properly. So how can you use these two slightly different, because before we've seen the vectorization chain was containing everything of the first chain plus vectors. In here, it's only containing the vectorization. So what you can do is, for example, you can define an additional field called vectorized, a Boolean one, that will effectively just show you on your documents which one has been vectorized and which not. And first you index again on the no vectorization chain. When you finish, you reindex all your document just doing partial updates, which means that for each ID of your document, you are just setting the new field as vectorized, but behind the scenes, this time, this will target a different chain, a different processor chain, so behind the scenes, Solr will vectorize. Why do we see the same problems? Because partial updates in Solr are better in terms of the fact that you don't push your documents through the network again, but behind the scenes, Solr will fetch them and reindex them anyway. So the same problem with deleted docs, and the merge factor is there anyway. So what's the takeaway? It's doable, can be good enough for your use case. But if you go in production on a massive scale using this naive approach or the slightly better with partial updates, you may experience some problems later on. So something we should do as a new contribution would be to just build the hierarchical navigable small world graph, which in Solr serve vector search. They are separate data structure. We could just integrate these in a way that, as a new way of partial updating documents, you just build the vector side of it without reindexing everything. It's a good idea. It's open for contribution Solr, so we will do it in the future. Anybody, of course, in the audience can contribute it, can help with that. So what happens at query time? So you've indexed, Solr vectorized your content. Now you have built the data structures in Solr, vector side. to run KNN search. But you want to run natural language search. So you can, of course, use like KNN. The KNN query parser was available before 9.8, but you may just want to send a natural language query and get automatically like relevant results. The first step is declaring in the Solr config XML the KNN text-to-vector query parser. So this is quite simple. Literally, you give it a name. This is the full name. You can call it as it pleases you. To be honest, there's no rules in there. And you just import the class which is in the LLM module. So you need to, of course, to enable the LLM module as said at the beginning of the talk. And then you can use this new query parser. Quite simple. It doesn't have many parameters, to be honest. You have like all the same parameters of the KNN query parser, so they are inherited. So you can use pre-filters, you can use post-filters, you can use, there are like some additional type of filtering, like including tags, for example, some advanced filtering. We don't need to give details now, but anyway, all the parameters of the KNN query parsers are there, plus the model name. So literally you call the model ID you configured in the LLM module. And behind the scene, Solr will use that, access the configuration, call the hosted service, encode your query, and run your KNN query. So the results you get are the top K nearest neighbors of the vectorized query. And also in this case, pay attention to the fact that as documents are sent to the model, also your queries are sent to the hosted service. Again, privacy and performance implications. So what are the next steps? So I want to spend a few minutes, we have 5 minutes before the questions on future works. So a natural evolution of this first step is supporting local models. As we've seen this morning with an interesting talk about GPUs from Radu and Rafal, local means different things to different people. So I'm not talking here about the first implementation of in-process, like text vectorization, because that's adding like a lot of resource consumption. In Solr, it's quite complicated, so I would probably skip that, at least for the first phase, but supporting like local models running in the local area network, for example, or anyway, like self-hosted by an organization. And this can be done using some sort of common interface, and then Solr will just call the interface, and behind the scenes, this interface will be implemented with some self-hosted text vectorization. That will solve like the privacy problem, and of course, like improve a lot on performance, potentially, if your self-hosted text vectorization is more performant of the hosted services. Another natural evolution is supporting vector search optimizations. So there are various optimizations in Lucene already that needs to be in Solr as well. We are talking about, for example, nested vectors and multi-vectors per document. It's quite a common scenario to have like chunks, paragraphs per documents you want to encode separately and run KNN search on the children and retrieve the parents. That's a work in progress. There is a pull request open and will be probably future talks in some other conference, and it's coming soon, probably in 1 month, a couple of months should be available in Solr. Quantization, so the ability of compressing your vectors to potentially get like cheaper memory footprint and performance, improved performance. Not much about the storage, because the current Lucene implementation will actually store a little bit more, because it stores the original vector plus the quantize. But there's progress in there as well, so potentially in the future we may get benefits also from a storage perspective. And new KNN queries. So right now in Solr is supported only the classic KNN query plus the vector threshold, let's say, vector similarity threshold. We may want to include also the seeded KNN query, which means that you start the exploration of the vector search graph from a set of results coming from a lexical query, for example. Right now it's random, so you start from random entry points and then you navigate the graph. And there's also an early termination implementation to offer like potentially, let's say, faster searches at the cost of early terminating, of course, some exploration of the graph. Other implementations that can be natural evolution of this is implementing general purpose large language models integrations, such as retrieval augmented generation, query document expansion. Given we have now LangChain4j in Solr, we've done the first big step to integrating a new library that can be used to talk with other models. So right now we are using it just for large language model fine-tuned for sentence similarity and consequentially text vectorization, but we could use LangChain4j in Solr to interact with general purpose models in a very similar fashion, right? Like you could call, instead of the Mistral AI for text embedding calculation, you can call the general purpose one. And this can open the doors for data augmented generation, query document expansion, large language model-based highlighting, which we have already a prototype we've built, and explainer as well, right? So you may want to use large language model to explain your search results to show your users why you got those results in the first place. From natural language to structured queries, we've done a talk with my colleagues Anna and Ilaria this morning. This can be integrated in Solr potentially. And better hybrid search, which has strictly nothing to do with large language modeling, but it's still something that you could do to improve this part of Solr. And the little end with like the money is because Solr is done by volunteers, right? So in case you're interested in this feature, you want to sponsor these contributions, you can do it with money, with developer time, with documentation help, whatever. You know, we are open to get everything. And I'm going to wrap up my talk with a QR code you've probably seen already in other talks. We are running a search community survey. It's focused on various open source search engines. It's a way for us to gather like trends and directions. We may then apply in Solr, or OpenSearch, Elastic, any Vespa, any other search engine. And it's going to be public. The results are going to be public. There's anonymity, so you need to pass your personal information. We shared this already. It would be wonderful if we get as much input as possible on this. And I should be in time for questions.
Amazing. So I would give opportunity for our in-person audience to begin with some questions, if they have any. Otherwise, I have 2 questions. OK, we have the first question.
Thanks, Alessandro. That was awesome. You mentioned the multi-vector nested vector support was in progress. Could you talk about that progress?
Absolutely. So the reason I put it nested and multi-vectors on the same line is because after some research in the Lucene space, we ended up agreeing on the fact that unless you move to like models such as multi-vector queries and multi-vector documents, such as, for example, Colbert for re-ranking or Colpali for re-ranking, if you have just one query vector and multiple vectors per document like chunks and paragraphs, the current implementation, which is like based on nested vectors, so effectively each vector is a child of the parent document. So it's a different document. It's a different Lucene document. It's actually like a quite decent solution. We couldn't find like any different way to do it better in terms of performance. So what is happening is in progress because the support for nested vectors through like parent block join currently in Solr doesn't guarantee top K retrieval of parents. So you just get top K retrieval of children. And with adopting the new Lucene implementation, you will guarantee top k parent retrieval. So you get unique children per parent. So you don't get two children for the same parent. You get the maximum score one, so the highest similarity. Right now, that's what you get out of the box. Potentially in the future, we may implement different metrics. And then you're able to return the parent and the best child for that parent. So potentially the content of the paragraph. And the reason then I add in multi-vectors here is because you may want to implement this in Solr through nested documents. So you push the document with the children, with like multiple other metadata potentially attached to the child. Or maybe it's easier for you just to add to the document, to the parent document, an array of vectors as effectively behind the scenes will be nested vectors. So behind the scenes, Solr will use the same contribution, will split this nested vector as children document and automatically do the query and the transforming, so the user won't see anything, but you will get the same effective implementation behind the scenes. So they are correlated. The nested one, so the one just exposed the capability of nesting, is already in progress. It's pretty much finished. I just need to merge it. The other one is pretty much finished, but I need to open the pull request and then get feedback from the community and potentially improve it.
That sounds good. I have a question. Maybe I'm nitpicking, but then what do you think is the value we would get if we enable doc values for the vector fields? I think on slide 23, there was a declaration. I was just, maybe it was hard for me to understand, but then I wonder, like, why would you enable like doc values for a vector field?
You wouldn't. I mean, there's no reason for doing it.
Okay, no, I thought there was something that I'm missing.
Okay, no reason. I think in the past there was an implementation, an original implementation leveraging like doc values, but nothing related with the current implementation, the current Lucene implementation doesn't need.
I think, do we have any question here in the audience? Okay, we have one. I should not take more advantage of being a stage host.
First of all, thank you very much for your work on dense vector search in Solr. I'm so glad you did it. Today we heard from several talks the major improvements we get from Lucene 10, especially with performance to vector search, memory management, and so on. And I'm so very much looking forward to getting a Solr 10 version in the future. I don't know if you are the right person to address this, but can you give us an impression when we might expect it?
Oh, I mean, giving a date is quite difficult. I would say that in terms of like priorities, the effort required to bring like, for example, quantization and new queries from Lucene to Solr is going to be a smaller effort than, for example, introducing local models, for example, because maybe in there may be some more tricky aspect of it, maybe LangChain4j has some, maybe incompatibility, whatever. So I would say, I don't know when I'm quite confident, given the interest I got from some potential sponsors, that we may see, and also some contribution. We started the discussions, for example, in the dev mailing list, to have like a dense vector search group coordinating like this shopping cart potentially. So we may get coordinated sponsorships. Some organization may help with this. So I would say that it's reasonable to think like as a 6-month kind of range to see at least all the Lucene stuff surfacing to Solr. And the other things, I would say probably local models and query document expansion and retrieval augmented generation to be following just after that.
But there's a follow-up, which is if you have a follow-up with Alessandro.
Yeah, I'm super, open to listen.
Yeah, there's a lot of people. Some people are speaking up, some people aren't. But it's a popular area, and it certainly helps to know the different things that matter to you, right? Because there's choices and priorities. So, speak up.
Just like myself, I have placed the ticket for quantization because it's extremely important for my use case. And thank you once again, Alessandro, for putting all your work and bringing so many features to Solr.
Thank you.
Yeah, this is really, really appreciated. And I think this man definitely deserves a huge round of applause before we head out for the get-together tonight.